Okay, today we'll be looking at other uses of the mole that we talked about yesterday, but not related to Avogadro's number. We're going to use moles and mass today. In order to do this, you need to get out your periodic table, so make sure that is handy because at different times we're going to be referring to it. I want to make sure you've got it close to you. Okay, first off, this is really a continuation of what we talked about in section 10.1 yesterday. And molar mass is the mass in grams of 1 mole of a substance. So if we had 1 mole of water, how much would it weigh in grams? That's its molar mass. If we had 1 mole of carbon atoms, how much would it weigh? That would be its molar mass. So literally it's the mass in grams of 1 mole of a substance. Now how do we find this? Well, that's why I asked you to go to your periodic table. The atomic mass printed on the periodic table really has two meanings. One, it's the average mass of one atom in atomic mass units, which we talked about back in first semester. And two, it's what we are using today. It's also the mass of 1 mole of atoms of a given element in grams. Now, when you go to find molar mass, you need to understand that whether we're dealing with atoms or molecules, it's a slightly different process because atoms are what the periodic table deal with. So really finding the molar mass of an atom, we can just look it up in the table. So mass of 1 mole of any atom is the same as the atomic mass in grams. Now, important note for this, whenever you're getting mass off your periodic table, you'll notice that a lot of times they have many decimal places. And when you look at it different periodic tables, to all the decimal places they show, sometimes you end up with slightly different numbers. Well, if we round to tenths, it's always going to be universally the same. So to keep it simple, whenever you get a number off the periodic table, I want you to round your mass to tenths every single time. So if you look on your periodic table, find hydrogen. Now, what would the mass in grams of 1 mole of hydrogen atoms weigh? Well, your table is going to say something like 1.008 grams, or maybe 1.0079. Well, if we take that and we round it to tenths, we're going to get 1.0. No matter what table we look at, we're going to get the exact same answer. Now, 1 mole of carbon atoms, well, look that up on your periodic table. Table I'm looking at says 12.011 grams. Well, when I round that to tenths, I'm going to get 12.0. Now, don't think that every element on the periodic table is going to go to a 0.0. Some of them do, but many of them don't. So, case in point, look up copper. Remember, that's going to be in the middle D block of your periodic table, up top there. And copper says 63.546. Well, to tenths, we're rounding it to 5. The next digit is a 4, so we're going to round down and we get 63.5 grams. So get used to rounding appropriately off the periodic table to the tenths, because we're going to use that a ton in the next few chapters. Now, for compounds, we kind of do the same thing, but we've got multiple atoms inside the compound. So for compounds, molar mass is the mass of 1 mole of the compound, and it's the sum of all of the masses of all the atoms. So if we're looking at the molar mass of water, so what does 1 mole of H2O weigh? Well, 1 mole of H2O has 2 hydrogens in it and 1 oxygen in it. So H2O, 2 H's, 1 O. Well, when you look up your numbers on the periodic table, hydrogen, remember rounded to tenths is 1.0, we got 2 of them, so we double it, that's 2.0. Oxygen was 16.0, and there's only 1. So 12.0 plus 16.0, that would be 18.0. So the mass of 1 mole of water equals 18.0 grams. Now, that would be the mass of 1 mole. Technically, if we're talking about what is the molar mass of water, we would write the units slightly different, because my question here was 1 mole of H2 equals what? Well, it equals 18.0 grams. But if we're going to express this as a molar mass, we always write it as grams per mole, because that's what it stands for. The mass per 1 mole, the mass per mole. So this is a complex unit, just like we saw last chapter. So as molar mass, it would be expressed as 18.0 grams per mole. So in your homework, whenever you're finding molar mass, put grams per mole, or you're going to lose a half a point on every single unit where it's supposed to be grams per mole when you're writing molar masses. Now, since molar mass is a complex unit, remember it's really an equality. So 1 mole of water equals 18.0 grams. Well, what can we do with it? Remember, I talked about this before. I said every time from here out in chemistry we establish an equality, the very next thing we will do is use it as a conversion factor in a dimensional analysis problem. So that's the second part of your homework. After practicing molar masses, and calculating molar masses, I should say, what you're going to be doing is using molar mass as conversion factors to convert back and forth between the mass of substance and its moles, or the moles in its mass. So case in point, how many moles are in 242 grams of water? Well, Remember, we start by putting down our target and our given and our workspace. So I've got moles of water. That's what they're asking me to find. Remember, I said two-part units. Use two-part units everywhere throughout your problems in this chapter. The exception is molar mass. You don't have to say that it's 18.0 grams per mole of water. I would take 18.0 grams per mole. That's fine. But when you're doing all the math problems, notice two-part unit, grams of H2O here. Two-part unit, we're trying to get 2 moles of water there. Now, the process, just like it's always been. Do I want to keep it? Well, no. I've got 242 grams of water, but it says I want moles of water. So I've got to get rid of the it, which is the unit, the grams of water. Two-part unit. So that means to get rid of it, I'm going to put it on the bottom. Now, what do I want to change it into? Well, I can put up top any unit that's equivalent to grams of water. Well, I know molar mass, because we just talked about it, is an equivalency between moles and mass. So I can go from grams of water to moles of water. You can go from mole or grams of any substance to moles of that substance and vice versa. Now we just need numbers to make them equal. Now remember the definition of molar mass. Look at your notes. Every time in your notes so far where we've talked about moles, the same number has always been by it. Avogadro's number was the number of particles in exactly 1 mole. Molar mass is the mass in exactly 1 mole. By mole, we always put 1. And remember, the mass is what we find off the periodic table. And we just did that for water. So we just established that water was 18.0 grams per 1 mole. So putting a 1 on top and 18.0 on the bottom makes them equivalent. It's a valid conversion factor. And at this point, my grams of H2O would be canceling. I'm in moles of H2O, so this must be the proper setup. So remember, everything on top multiplied, everything on bottom divided. So 242 times 1 divided by 18.0, rounded to correct significant digits. Remember, your calculator is going to give you a bunch. Starting number 242 has 3, 18.0 has 3, because remember, it's a rounded value. It has limited significance. And our 1 mole, that was exact by definition. So we've got two things with 3. We're going to be stuck with 3 sig figs. So regardless of what our calculator prints out, we're going to write down 13.4 as our appropriate reported answer. Now, that would be taking a mass and figuring out how many moles it is. Now, since there's no such thing as a mole balance, this is how we always find the moles of a substance. Is if we know its mass, we can convert it to moles. Now, if we did know how many moles of a substance we had, remember, it wasn't measured. Somebody figured out and said, you've got 3.77 moles of gold. You can actually figure out the mass of that. Same process as before. We need our target off on the right. That'd be grams of gold. And we're given that we have 3.77 moles of gold. Notice the two-part units. Don't be lazy. You got to write them both or you're not going to get full credit. So I don't want moles of gold. Now it's going to go on the bottom. I would like to convert it to grams, so I'd like to put that on top, but I need an equality. Well, that's what molar mass is an equality between those two units. And remember, the mass comes right off the periodic table for gold because it's an atom. We don't have to add anything up, but we round it to tenths. And by mole, we're always going to put that 1 because by definition, it's exactly 1 mole. Now, as far as our final answer here, since our units cancel to what we want, this has to be our solution setup. So multiply everything on top, divide by everything on bottom. In this case, round to 3 sig figs because 3.77 moles had 3 and our molar mass had 4. So 3 is going to be smaller, round to 3. So that's basically what you're going to be doing with today's homework. So good luck.